And good morning everyone, welcome back to another video here in the Off-Grid Garage. Well, it's morning here at least, I don't know what. Well, I guess today is the day. We will finally measure the capacity of one of these battery cells. I have everything prepared and I just measured the voltage of, and we have 3.6, almost 3.6, can you see? Yeah. 3.59 volts, so we are close to 3.65. The battery is still connected to the buck converter, which is connected to the solar panel. Well, I need to tell you, I was a little bit impatient during the week because the last video I made about this whole setup with the lights here was 1 week ago. And I said I will fully charge the battery just from my solar using this buck converter. I needed to go back to work and I wasn't brave enough to leave everything up and running here while I'm at work for 8 hours and couldn't monitor, couldn't measure the voltage and everything. So because we don't have any overcharge disconnection circuits, nothing, no protection on this battery cell apart from a circuit breaker there. Yeah, so anyway, what I did is I used one of my old computer power supplies here, 380 watts. And yeah, modified this one so I can get, well, 12 volt or 24 volt even out of this power supply with around 20 amps on the 12 volt, 17 amps on the 12 volt. Yeah. Yeah, if you're interested in how to modify such a power supply, let me know. I'll do a quick video and rundown on this one. It took me around 1.5 hours to get this all done. So this is now a nice benchtop power supply and we can use this in the future to charge our battery cells. I used actually this one in the evenings when the solar was not working anymore to charge the battery on a higher amps. And well, we are almost done, I think. Just quickly measure the current going into the battery. Yeah, 1.2 amps only into the battery. So we are very close to 3.6 volts and 3.65 is the cutoff voltage for this battery cell. Okay, let me clean this all up here a little bit. It looks fantastic, I know. And then we start our capacity test once the current goes to 0. Okay, the battery is still taking 100 milliamps at the moment. Yeah, I think it's full now. Quickly the voltage again, 3.67. So we are a little bit over the 3.65. Okay, I'll stop charging now and then we put the lights on to discharge everything and measure the capacity. I have properly cabled everything with ring terminals now, 4mm cables, cable terminals, XT60 connectors all about. So this is just to minimize all the losses in the connections and cabling. We are powering our energy analyzer with this 12 volt battery. So even if we disconnect the battery or if the circuit breaker trips, we will still have the results here. All right, let's get this on the way. Turn this one on, Christmas lights coming on. And we are discharging with 21.5 amps. Okay. I think this will drop over time anyway, because this is only a 20 amp circuit breaker. I have 20.86 and we have 20.9 here, so very close. Okay, and now if you take the capacity of 280 ampere hours divided by, say, 20 amps, this is like 14 hours. So this test will take 14 hours. It is 8 o'clock in the morning now. Oh, this will be a late night show. Okay, so this will run for 14 hours now, in theory, if the capacity is 280 ampere hours, and we will have a result tonight at about 10 p.m. Okay, I'll keep you informed during the day if something interesting happens. If not, we will see us again at 10 o'clock tonight. Okay, so we are now 14.3 ampere hours into the test of the projected 280 ampere hours. And I just measured the voltage again here on the battery directly, and we've got 3.3 volts. And this is quite normal that the battery, when it's fully charged, shows 3.65 volts, but then you put some load on it, or even you take the charger away and the voltage will drop. And if you have a look at the discharge curve of such a lithium-ion battery, you can see the 3.4 volts will only be achieved at the very beginning when the battery is fully charged, and as soon as you put load on it, if you take 1% of the battery, you already are down to 3.3. 3.3 volts and 3.2 volts is the nominal capacity, is the nominal voltage of these cells. And look at this curve, it's almost flat until right the end, when we reach around 90%, and then we should see a fall of the voltage as well. And at 2.5 volts, I have learned this now with these cells, 2.5 volts, we will stop the test, and then we've got our capacity. Secondly, after half an hour into this test, is it half an hour? It is half an hour, yes. This circuit breaker gets really warm. Because we are pulling 22 amps, and this is a 20 amp circuit breaker, it will heat up, and I think it will trigger very soon. I've got a 25 amp circuit breaker here. This is a 3-pole. I'm using only one of these circuit breakers for that. So as soon as this one trips, I'll put this one in, and then we continue the test. It doesn't really matter because this one stays alive even without the battery being connected. It has external power supply. Well, so far everything is working well. And what I've also noticed is even at 20 amps, you can feel the cabling is getting warm, and you can also feel the connectors, the XT60 connectors, are getting a little bit warm. All right, I'm just checking on our setup here after 5 hours now, and I was wondering why we have hit 65 ampere hours exactly. Just wait for it. There, 65,000 ampere hours. And I watched the meter a moment and could see these 65 ampere hours, they are not moving. So obviously this is the maximum this meter can measure. We are hitting the ceiling, and 65 ampere hours is the maximum this meter can show on the display. So this test failed. Well, on the positive side, we still have the watt hours. There you go, 316.5 watt hours. So we have almost discharged a third of a kilowatt hour out of this battery now with this setup. And the watt hours are still working. I'm not sure if we, well, hit a limit there as well at some stage, but at the moment they are counting. And we can calculate the ampere hours by dividing the watt hours by the voltage. And I've read in the manual here of this meter, of this power analyzer, there's nothing mentioned and there's a maximum of ampere hours it can count. I checked online as well on the website, and there's nothing specified for these devices that they hit a ceiling at some stage. So it's still 65, but here 317.6. So this is still going up. We have to go with the watt hours. That's fine. And let's measure quickly the voltage of the battery as well. 3.26 we have now, so it has dropped by 40 millivolts in 5 hours. So that is pretty good. And also surprisingly, I haven't replaced the circuit breaker yet. This one is pretty hot here, really. 44 degrees it has. But it's still holding. Even we are overloading the circuit breaker by 10%. Well, the other one is here just in case. There it is. 65 ampere hours. 358 watt hours. I just did the calculation for that, and we have now discharged 108.8 ampere hours of this battery. Well, it is not 100% accurate because the voltage is not constant. The voltage will drop from 3.3 to a 3.2 volt, and then eventually will go further down to 2.5 volt, and then we stop the whole show anyway here. But it gives us a good indication how many ampere hours we've got out of it. I mean, watt hours are not bad either. If you know you can get 1 kilowatt hour out of such a battery, and you've got 16 of them, that would be amazing. So 455 watt hours would be 50% of the capacity, and we have now 457. So 50% mark reached. 3.25. Still going very strong. Well, what I'm going to tell you now, you need to be very brave. It is in regards to the capacity measurement I started yesterday. Well, I messed up. I totally messed up. I had my clamp meter here to measure amps and volts, and I measured here the battery and here the inverter and there the solar, and measured there and here. And somehow with these leads attached, which are necessary to measure the voltage and everything, I must have bumped the cable of the auxiliary power, which is necessary for our analyzer. So the analyzer display went all berserk. Oh, you can hardly see it with the sun now. See, this is only these two little cables in here, which are feeding 12 volt into the analyzer, because the source voltage of only 3 volt, one cell, is not enough to power this one. So it needs auxiliary power. And somehow these measure leads, these probes, got tangled up with the and it disconnected the power analyzer, and this happened at around 82-85% of discharge already. So we were very close, only 2.5 hours until our result, and it stopped measuring. This is totally my fault. This is totally my fault. I apologize. I have to do everything again, but it won't affect the video. I just want to explain. I actually just needed to talk to someone, so thanks. So that was yesterday, and I immediately hooked the battery up to my power supply again and started recharging it on about 9 amps. And this morning I hooked it up to the solar, so I'm using the solar now to recharge the battery cell. And I hope I get this all recharged until tomorrow morning, because tomorrow is Sunday. And I hope I can restart the measurement again, the capacity test again tomorrow morning. So we will have a result at the end of Sunday tomorrow. That's the plan. And I will be rearranging this whole stuff here. So I'm getting rid of these fly leads here and make sure I cannot bump anything, and make sure this is all good contact and the actual analyzer is working. I got so angry yesterday. I would appreciate if you don't tell anyone, if possible. All right, my friends. It is Sunday evening, Sunday night, and we are still testing the battery. So this is the second test. I started this morning at about 9 o'clock, and it was supposed to go until about 11 o'clock. So 14 hours with this load to discharge the full capacity of 280 ampere hours as per the specifications of this cell. Well, what can I say? We have now 8:15 in the evening, and just measuring the voltage again, we are at 2.59 volts already. Now you can see it, 5.8, so it's declining. And we have pulled out 777.6 watt hours so far. 777 divided by 3.2, which is the average voltage we had, are 242 ampere hours so far. And I think we are very close to the cutoff of 2.5 volts. Yes, we are. There we go, 2.5 volts. We will stop the experiment now and turn off the power. There we go. So this is all turned off, and we will have the final result. 778.4. 778.4 divided by 3.2. So 243 ampere hours out of the 280, and this is with 1/10 of a C. So we have pulled only 24 amps out of the battery, and it took exactly 11 hours to discharge the battery from fully charged 3.65 volts to now 2.5 volts. And this is the cutoff voltage as per the specifications. And this results in 243 ampere hours and not 280 ampere hours as advertised and sold. Well, the voltage during discharge was between 3.3 and 3.2 volts most of the time. But at the end, of course, if you remember this curve, you can see it's falling off fairly quickly. So if I assume a higher voltage of 3.22 volts, we are only getting 241 ampere hours out of this battery, not 243. So the higher the voltage we assume, the less ampere hours we get out of it, of course. Well, the battery was fully charged this morning to 3.65 volts. It had 0 amps going into the battery. It was fully saturated when I started this test. And I hooked up the power analyzer straight away to all my lights here and discharged the whole battery with 1/10 of a C. So about 24 amps continuously over 11 hours. And these are the results. I'm not sure. What do you think? Is this the cheap power analyzer which is not correctly calculating? Or is this my wrong calculation of the voltage? From what I measured during the day, it stays between 3.3 and 3.2 volts until about 80%. And then you can see it dropping off below 3.2 volts. So most of the time it will stay above 3.2 volts. So I'm not sure. Should I test another cell? It's maybe just this one because this is damaged. But I don't believe this dent actually makes a difference at all. Yeah, well, guys, 87% of the capacity I could discharge from this battery cell. Okay, guys, before everyone is freaking out and saying these are cheap Chinese batteries and everything, by the way, this is the next day now, so I have some doubt that my measurement is really accurate here, what I'm doing. I'm calculating watt hours to ampere hours by using a constant voltage. So I think my assumption of 3.2 volts is a bit off, because we certainly don't have a constant voltage while discharging this battery cell. We're starting at 3.65 and then ending at 2.5. But most of the time it stays between 3.3 and 3.2. So what is the average then? We don't know exactly, right? And that's why the ampere hours would be the better result. But this cheap $7.50 power analyzer does not do the ampere hours above 65 ampere hours. That's when it hits the maximum it can count. I am in contact with Joseph from the United States, and he has bought these batteries as well. He commented on one of my videos and we got in contact and exchanged some thoughts. And he's got the same batteries as I have here, the 280 amp hours batteries from the same factory. And he put them in series and did a capacity test, and you can see he could get 273 ampere hours out of these battery cells. But then again, it was only 17 degrees when he did the test, so the batteries were a little bit colder, because the specification says the battery needs to be on 25 degrees, which gives you more capacity. And also there was no BMS attached, so when he did the first test, one of the cells was still above 3 volts. So they were not correctly balanced maybe. But then you can already see you come very close to the advertised 280 ampere hours of these batteries. So I think we have to wait until all the equipment is here. I can do a proper capacity test, a proper discharge test and everything. And I'm currently sourcing more equipment like solar charge controllers and inverters. But again, looking at the specifications and the discharge curve or graph they supply with these cells, you can clearly see they did the discharge of 285 ampere hours at 1C, which is a super high current of 280 amps. And usually batteries don't perform that well at these high amperages because the internal resistance and internal heat loss increases a lot and you get far less capacity out of it. But they are confident they are getting 285 ampere hours out of the battery at 1C. And then when you look at the graph they supply, even at 0.1C, and this is pretty much what we did with the light bulbs here, you get only marginally more capacity out of these cells. And this tells me we have a very small internal resistance here. So these must be A-grade cells. Otherwise, they wouldn't be confident to advertise this like this with 5 years warranty and such a high discharge current when doing their capacity test. So there is a very high confidence level with this company to offering these batteries. And as I have discussed with Joseph in the US, and he also thinks that these batteries are underrated, so they are promising, or they're offering a smaller capacity than the actual battery actually has. So we may end up with batteries having 300 ampere hours as well as 280 only. I mean, they're just trying to minimize returns and claims of faulty batteries and everything. So they usually underrate their advertising a little bit to be on the safe side and don't end up with heaps of claims of faulty or not working batteries, or batteries with less capacity. So please take this result here with a good grain of salt. And yeah, I know this is not the correct test environment, test equipment I've used here, but I thought I'll give it a try and see what we come up with. It's always good to have a second opinion than what I got from Joseph over there. And also when the other equipment arrives, we do more testing, of course, of these battery cells. And I think we will get close to 280 ampere hours, if not exceed that. All right, guys, let me know what you think. And as always, thank you so much for watching. And we shall see us in the next video very soon. I promise I make more videos now. I was a bit busy in the last couple of days, so I didn't make so many videos here. But we are on a good way to do more stuff with batteries. Absolutely. Okay, thanks again and see you later.